Good morning, all of you. I'm Dr. Kanade, and we will start our today's lecture. The topic of today's lecture is PIC18F458 Assembly Language Programs. Let me clarify in the beginning that uh, these assembly language programs that we are going to see are part of the first unit of your AMA subject only. These are very basic programs, and they are going to be using the instructions that we have studied in the previous lectures so far. We have studied three types of instructions so far: data transfer instructions, arithmetic instructions, and logical instructions, right? Very simple instructions we have seen, and we are going to use only those instructions right now, okay, in these programs. Okay, so let's start with our first program. And as we know, program means solving some kind of a problem. So the first problem statement here is write a PIC18F458 assembly language program to add contents of file register 0x40 to the contents of file register 0x41 and store the result in file register 0x42. Okay. The programs that we are going to see today are almost having the similar kind of structure. The differences would be in the addresses of the registers. Okay, so in order to solve any programming problem, first we'll have to break down the problem into steps. First we'll have to understand what is asked in the program. Okay. So as far as this program is concerned, what it says, what we have to do, write an assembly language program to add the contents. Okay, so here we will have to use some kind of an instruction for addition of the contents. Then the next section of the problem is there are two registers given, register 1 which is 0x40 and register 2 which is 0x41. Okay, remember these are not values. What are these? These are registers. We have to add the contents of these registers. Okay, and the result has to be stored, means the addition of the contents of these two registers has to be stored in file register 0x42. Okay, so remember, whenever we are talking about any problem, we must pay attention to the numbers whatever are given and whether those numbers are data or registers. In this case, there is no data given, all are registers, means register 1, register 2 and register 3. We have to add contents of register 1 with the contents of register 2 and we have to save the result in register 3. Okay, solving any problem will involve you to write sequential instructions for how to tackle this problem. Okay, so let's see how this problem can be solved. Okay, now while we are talking about the problem, you should also recall the instructions that you have studied so far. Okay, what instructions you have studied? You have seen data transfer instructions and arithmetic instructions. For the moment, logical instruction is not required in this program, so let's keep that aside. Okay, so data transfer instructions means you move values from one register to another, right? And in arithmetic instructions, you add either some direct value to a register or to W register, or value in a register to W register, like this. So we'll have to use some of these instructions in this solution of this program. So the first step should be, we have two registers. So first register, the contents of the first register, we will copy to W, because remember the addition operation that we have seen, the addition instructions that we have seen, one of the operands is always W. Addition of instruction always works on contents of working register W. So what we will do in this program is we will copy the contents of one register, let this first register into W, and then add the contents of this register to the contents of W. Okay. So the first step, what we'll do, load the contents of memory location 0x40 to W, right? Remember, this is, again I'm repeating, this is not a literal value. This is address. This is a register, right? This is a memory location. So that's why these brackets around 0x40. You remember while discussing the instructions, I have told you that the brackets indicate the value at that location. Okay, so we have to find out an instruction, or we have to write an instruction which will transfer the contents of 0x40, means the value at 0x40 to W. So this will be our first step. Then in second step, what we will do, we will add the contents of 0x41 to the contents of W. Okay, again remember, here what we have, contents of W plus contents of 0x41, means the second register. In the first register, what we have, because of the first step, contents of W are already copied to contents of 0x40 are already copied to W. So in W we'll have the value here of value from this location, and here, since again we have round brackets around 0x41, the contents of this location will be added to contents of W, and the result will be stored in W. Now W has the result of addition. What is asked? Store the result in file register 42. So we will use a simple instruction, again the third instruction, contents of W, that's why round brackets, go to the location 0x42. Okay, so these are the steps for solving the problem. Now the most important part, how to convert these steps into instructions. Okay, so let's see the instructions for doing this. Okay, now remember, whenever you are writing an assembly language program, you must have these three columns in a table. Let's say first you will have a mnemonic, means the name of the instruction, then you will have operands of the instructions, and then finally you will have the explanation. Remember, many students do write the program and do not write the explanations or comments. For AMA, you should make a habit that you must write these comments all the time for all the instructions. Okay, what happens normally is, as in any programming language, there are different ways of solving a program or writing a program. Okay, for a particular problem you may have different solutions because of the different ways of thinking of people. So some of you may use this instruction, some of you may use some other instructions, some of you may use BSR or whatever. So the programs may change, and the problem would be the examiner will not, I'm talking about when you are writing the programs in your examination, theory examination. The problem would be the examiner may not read all the instructions and try to decode the program every time. That's why these instructions, these comments will play a major important role for helping you to get marks. Okay. Okay. Now, what was our first step? To load the contents of memory location 0x40 to W. For this, we have studied one instruction called move F. Okay, move F was the instruction that we have studied. Now, can somebody tell me the format of this instruction or syntax of this instruction? Anyone? Somebody tell me the syntax of this instruction movef. You have seen this instruction in our previous
The
lectures.
move in file register, na?
Yeah, but I'm talking about the syntax. What are the operands required for the this instruction? Means like for some instructions, what we have the name of the instruction, then F, comma D, comma A, something like that. So what is the format for this instruction particularly? What is the format for this particular instruction, movef instruction? Do you guys take notes? Do you guys write something whenever I'm delivering the lectures? You should make a habit of writing your own notes from these PPTs. Okay, otherwise what will happen, the lectures will go on, you will listen to the lectures, and ultimately you will have nothing at your end. You should write down whatever goes on the slides. Okay, anyway, so I will tell you what
Move value and memory.
is or the syntax. Movef has two operands.
Yes.
First one is F, okay, and second one is what? What operand? Somebody want to tell me what are the operands?
D.
Actually, movef has three operands, okay? F, D, A. See, you can also understand this from the instruction also if you have studied the instruction properly. Movef, what is it going to do? This instruction is going to move or copy contents of F. Okay. Now, since there is F, there has to be A, right? If there is F in an instruction, because this F is 8-bit, okay, F is address of the file register. Now address is always 12-bit. So if there is F in any instruction, there will always be A in that instruction. Okay, so third operand actually would be A, but we can skip this operand. By default it will take value 0, means access bank. Okay, so 0x40 will be taken as 0x040. This will be the full address of F, automatically taken, because A in this case is absent, means A is 0, means we have to use access bank, and therefore 40 location in the access bank stands in the bank 0 or in the very top of the data memory location, at the very beginning of the data memory location. And there is a D bit. This is the D bit. The value here for D bit is given as W, means whatever the contents of F, means this location are, those contents are going to be copied to W, means the working register. That's why this instruction, what will it do? It will load the contents of memory location 0x40 to W. Okay, remember, it is not copying 40 value, it is copying the contents of that location to working register W. Okay, now the next instruction, next step that we saw was add the contents of 0x41 to contents of W. Again, we have seen an instruction for this, add WF. Okay, again in this case, A is by default 0, means access bank, means this location is coming from access bank. Okay, means again the actual location will be 0x041. Okay, by default this will be the actual location. And what is this instruction going to do? It is going to add the contents of W with the contents of F and going to store the result in
W.
W. Okay, result will be stored in W, because here we have written W. Here we can also write 0, okay, so that it will be again mean the same, that the result will be stored in D is equal to 0 means destination is working register. If we write 1 here, what will happen? The result will be stored in this register, in the file register, okay. But our next step has to be what? The result we want to copy to 42. That's why we keep the result in W, and in a single instruction further we'll copy the contents of W to file register 42. So for that we have this instruction, move WF 0x42. This is the F, okay. What is the format for this instruction? Syntax: move WF F comma A. There is no D in this instruction. You can go back to our previous lectures. The links are available on Moodle also. Links I have posted on your our TE group also. The PPTs are also available on Moodle. Notes are also available on Moodle. So you can go there and check. The syntax of move WF is move WF comma F comma A. This is only to indicate what is the F. D, there is no question of D, because this instruction is straightforward. Contents of W are going to be copied to F. Okay. So what was the content of W at this location? W held the addition, result of the addition, right? So that result of addition is now getting copied to 0x42. And since A is 0, A is equal to 0 means this is from Axis Bank. Now, why am I focusing all the time? Why am I talking about the Axis Bank every time? Is because whenever these register addresses are given, okay, now this is our first program. That's why I have taken the very simplest of the programs, where all the register addresses are only 8-bit addresses, 40, 41, 42. These are very simplistic addresses, I would say. I have taken the 8-bit addresses only, and all of these are falling in the Axis Bank. What was the addresses of Axis Bank? Can somebody repeat? Axis Bank, if I draw like this, okay, Axis Bank had 2 sections, right? There were 2 sections. The first one was 000 to what? 05F, okay, and then F60 to FF. These are the actual addresses of Axis Bank, right? These are the actual addresses of Axis Bank. Most of the times, like in these instructions, you will find that the address of the F or address of the file register is given by 8 bits only. So those 8 bits are these lower 8 bits. Okay. Now you can see here in this particular problem that all these 3 registers that were given in the instruction in the problem was where 40, 41, 42. So they are all falling in this section, right? So I don't need to specify this upper nibble or upper 4 bits of the data memory address, because by default I can take it as 0, and by default it is coming from Axis Bank. Okay, but what if these locations are not from Axis Bank? Then how we are going to tackle the problem? For that, let's take another example. Okay, here the problem is very similar. Okay, what has changed? See, what was the problem in the first what was the first problem? Add the contents of register 1 to the contents of register 2 and store result in register 3. Okay. Similarly, we are having another problem. Add the contents of file register 1 to the contents of file register 2 and store the result in file register 3. Okay. So one may say that this is the same statement. So we can use the same program as it is, and we will we will get our thing done. But the problem is different completely in this case, because if you notice the addresses of registers, what is the difference here? What is the difference? Somebody tell me what is the difference here between the first problem and second problem. The addresses now are how many bits? This is a hexadecimal value. So the addresses now are 12 bits, means the full addresses of the data memory locations are given here. Okay, full address of data memory location means the address of F is given in a 12-bit form. And here, because of this full address, we'll have to take care that we'll have to first make sure where these actual memory locations are located. Okay. So if you can look at your previous diagram, okay, I will myself show you, because I don't think you have taken notes with you. Okay, I will reopen the another PPT where I can show you this diagram. You remember this diagram? Here is in this section is the data memory. Okay, in this section we have the data memory, and what is given in the instruction was we are given the full memory address, and those addresses fall somewhere here, right? 242, 243 or 342, something like that. Means those are not in the access bank. Those are not in the access bank, but those are somewhere in the bank 2 or bank 3. Okay. So for using the bank 2 or bank 3, what we need to choose the BSR, right? We need to use the BSR mode. That's why we will have to load we will have to select that particular bank by loading value in BSR, and also we will have to use this A is equal to what? We'll have to use the access bit as A is equal to 1, so that we will have the BSR mode selected. Okay. Now coming back to our original program. Okay. Okay. So here, what we have to do, since the first register is in the second bank, bank 2, not second, it is actually third bank 012. So it is in bank 2 and the other two registers are in bank 3. So what we will have to do is we have to select the particular RAM bank. Here we want to select bank 2. So we will have to load value 2 into the BSR. Okay. And then we will have to use the instruction to copy the contents. Okay. Now the copy the contents of file register to W, the instruction will be same as before, but the difference would be here A will have to be 1. A means what? The access bit will have to be 1. We will see on the next slide the actual instructions. Similarly, for the next register, we will have to use the RAM bank 3 by loading the value 03 to BSR. Okay. And then we will add the we will use the addition instruction. Again, in the same manner, only difference would be A will be 1. And then copy the contents of W to the file register. Here also we have to select bank 3, but since 3 is already loaded in BSR, we don't need to repeat that step. Okay. So now converting these into the instructions, okay, what change has happened? An additional instruction has popped up, that is move LB. Remember this instruction from our previous lecture? Move LB is the instruction which copies the value, the literal. Here L means the literal value 02 is copied to B, means BSR. So value 02 goes to BSR, and that indicates that we have selected RAM bank 2. And in order to use this RAM bank, we will have to use here value of A is equal to 1, means the access bit is 1 in the instruction. The instruction is same as before. Move F means this instruction is going to copy the contents of F. Now F is 0x40. Okay, this you may say that it is the same register, but it is not. It is what? It is 40 from bank 2. Bank 2 register 40. That's how it comes to be 240. Okay. So the contents of 0x240, okay, 0x240 go to W. Okay. F, D, A. D in this case is 0. That's why the destination for the data is W. Okay. Now to access the second register 341, we cannot use the instruction directly because we have to select third the 03 RAM bank. So for that again we will use move LB 0x03. Again this is a literal value, okay, 03, which is going to BSR, okay, and that way we will be able to select RAM bank 3. The add instruction is same as before, only difference is 1. A is equal to 1 means access bank is not used. We are using BSR mode, means this 41 is from bank 3. That's how the full address is going to be created. Okay. And then finally, after the addition, the result is going in W, right? And finally, we will use the last instruction move WF. What it has? F, comma A. A here again is 1. Means we are going to use BSR. Value of BSR right now again still is 3. We have not changed BSR after this instruction. So the contents of W, see, contents of W are going to register 42 in bank number 3. That's why what happens? The result of addition is now getting stored in the file register 0x342. Remember the difference between the first and second program. If you are dealing with only 8-bit values, 8-bit addresses, then you can use the default access bank. But if you have 12-bit addresses specified in the problem where it is not bank 0 and it is some other bank, then you will have to use the BSR mode. Okay.